In this video, I'm going to explain this section of your book 3.8, converting a circuit to an FSM. So you're given a circuit, right? Here's your circuit with all the combinational logic and the control registers down below. And you're asked to come up with the FSM. So the next step would be to give me the equations that represent the combinational logic here, and then fill out the state table and then create the state diagram. So if you let this sort of play itself out, I mean, we can kind of see what's happening. So your inputs are P1, P0, and B. Here's your external input B. So you know you're going to have 3 inputs, therefore 8 rows on your state table. So go ahead and fill out the left-hand side first. Your outputs are going to be N1, N0, and Y. And so now look at the difference with the way your book draws this versus how we've been doing it. So inside your register, you know you need 2 flip-flops, right? A flip-flop stores 1 bit, so 1 each for these. So since we have 2 flip-flops, we would label them as a D flip-flop, so D flip-flop 1 or A, D flip-flop 0 or B. Same thing with the JK. So if we did a JK flip-flop, we'd label it 1, 0, or AB. Same idea, but the idea being that you have 2 flip-flops inside this register. Okay, so the next step is going to be to derive the equations. And here you can see, you could go through the process and do that at this point, right? You have an OR gate here with 3 inputs for N1. So N1 is going to be equal to this AND gate plus this AND gate plus this AND gate, right? All 3 ORed together. This one is the value of P0. Just follow your lines. And the value of B complemented. So the circle implies the complement. The next one is going to be P1 with B complement, and the next one is going to be P1 with P0, right? So those 3 OR together. Now that's how we came up with N1. You could do the same for N0 and for Y to derive the functions, and then fill out the truth table. So let's let this play. And it's going to give us each of the functions for N1, N0, and Y. And now let's take a look at how the truth table is filled out. I'm just going to pause it right here. Okay, so right here for N1, you'll need to figure out where the 1s belong. So it's a matter of plugging in the values to see where this AND results in a 1, where this one results in a 1, where this one results in a 1, right? As long as one of these is 1, the whole thing is 1 because you're ORing. So take a look at this, P0B complement. So look for P0's values being a 1. That's these 2 right here. Now complement B, right? That would be this one. So it would be 1 ANDed with a 1 gives you a 1. This one wouldn't work because complement of B will be a 0, so that would be a 1 ANDed with a 0 gives you a 0. You could look down here. Again, it's P0 with the complement of B, right? So this would be 1 ANDed with a 1, that gives you a 1. This would be a 1 ANDed with a 0, gives you a 0 in that case. So either of these would be taken care of by the first minterm. The second one, P1 with B complement. So again, look for P1 having a 1, right? And then look for B being complemented to a 1, because you know you're going to AND those 2 values together, and that's where this one comes from and this one comes from. And then the last one is P1, P0. So P1, P0, they're both 1s in these 2 rows, and that's where you get that. Okay, so now we're going to go through and do the same thing for N0. Let it play itself out here in the participation activity, and you'll see it do the same kind of activity. And then finally, Y, P1 ORed with P0, right? So wherever that's a 1. So P1, the complement of P1, all of these are 1s, right? So all 4 will definitely be 1s, because as long as one side is a 1, the whole thing is a 1. And then if you look down at these 4, even though these get complemented, you got to look at the values for P0. So these 2 will get complemented to 1, right? And that's where these 2 come from. Okay, next step is to create the state table. So look at your states. You know you have 4 of them, 0, 0, 0, 1, 1, 0, 1, 1. So go ahead and draw those. Now they're going to give them names S, T, U, and V. So when you draw them, they'll use that naming convention for them. Once that's done, then assign your outputs. Remember, your output is related to your present state value, right? If you look at that comes from this. The present state value tells you what your output is going to be. So 0, 0, y is a 1, 0, 1, y is a 1, 1, 0, y is a 1, 1, 1, y is a 0. Let that draw. And then the next step will be to go from your current state, right, with an input of 0, what will your next state be? So draw your transition lines at this point. So from 0, 0, on a 0, I'm going to go to the next state T, 0, 1. So draw that. B being 0 is B complement. So let's let this finish. The next one is 0, 0 on a 1. So B is 1. Stay in 0, 0. So it's going to go ahead and do all of that. I think, let me see. And I believe once that's all done, right, you're all set. And so you're assuming S is your initial state. You're starting in 0, 0, and that completes the circuit to FSM.